LiSTNR production.
A warning. This episode contains references to violence against women. Please listen with care. Welcome to Crime Insiders Forensics. For those joining us for the first time, my name's Kathryn Fox. I'm a former GP, crime author and screenwriter. I'm enthralled by forensics and have spent thousands of hours researching for books and screenplays. So I thought, why not turn my research into a podcast? Every week, you'll be joining me in discovering how forensic science is helping solve high-profile crimes in Australia and around the world. This week, how mathematics helped convict one of Scotland's worst serial killers and solve a 500-year-old royal mystery.
The maternal line DNA and the paternal line DNA, although only small amounts, only a fraction of your genome, they don't get broken up every generation, and so they're useful over 20 generations.
Professor David Balding is a genetic statistician who has assisted police in solving a number of high-profile crimes across Australia and the UK. His combination of maths and forensic science expertise can calculate the probability of DNA from a crime scene matching that of a suspect. While this may sound straightforward, this couldn't be further from the truth, with scientific advances making DNA analysis and detection more complicated than ever.
We were up into the sort of millions of times, more likely if it came from these two men. Nowadays, with DNA evidence, we're often into the billions.
To begin, David tells us how a mathematician became involved in putting killers behind bars.
Well, so first of all, I did maths at Newcastle in New South Wales and was lucky enough to get a scholarship to go and study further for my PhD at Oxford. It's funny how things just turn on an edge, because I was initially turned down for that scholarship, but then at the last minute they said, we've had someone pull out, are you still interested? And so I arrived late because of that. And I did my maths PhD in Oxford, nothing to do with genetics or DNA or anything. And I was planning to come back. I had a job in Brisbane, but basically that just got trumped by a better offer in London. And so I thought, I'll stay a bit longer in London and experience that for a bit. And I met up with a geneticist. And all of my experience with DNA really kind of results from a seminar that I didn't go to. There was somebody from the Metropolitan Police came to the university I was working at and talked about this newfangled DNA evidence that had just come in and was quite controversial, and talked to the genetics department, so I wasn't there. But my geneticist friend told me about it, and we worked together. And so, I had the sort of mathematical expertise mixed with his genetic expertise. We felt we had some ways of moving forward to analyse the strength of the DNA evidence. The big problem at the time was, okay, we've got a DNA match, but can we be sure it's him? How can you put a level of certainty on that? Because the early days, the DNA profiling wasn't as good as it is now, so it wasn't just completely straightforward.
I suppose if you compare it to fingerprints, when they took the first fingerprints, they had no idea whether it was a unique fingerprint or whether 1 in 10 had the same or 1 in a million had the same sort of thing, until you get a database, until you get more and more information about what you're testing. It's very difficult.
Yeah, it was interesting, though, because the fingerprints came in much earlier. They really should have faced the same level of criticism, but it was so much earlier that it wasn't questioned too much. And there was some good work done way back in the 19th century about the strength of the evidence for fingerprints. But when DNA came along, because it was very new science at the time, a lot of scientists got interested, and so inevitably there's a lot of controversy. People were talking about, the method's not completely foolproof, there's risks of contamination, and with genetics there's issues of relatedness. So DNA profiling is a bit more complicated because you're more likely to match with a relative. And so what happens if you're accused of a crime that was actually committed by your relative? How do you deal with that problem? So there were all these issues to deal with, and my geneticist friend and I got involved in these questions.
So what was your first step towards law enforcement involvement?
Well, as a result of the forensic scientist from the London Metropolitan Police was a kind of friendly guy. We got in touch with him and talked about our ideas, and we went over and visited the lab at near Waterloo Station. For those who know London, in a sort of bit of a bleak part of London, there was the Forensic Science Lab, and we went and talked with them and worked out, what was needed and what we could contribute, which, of course, we couldn't solve all the problems, contamination and so on. There's not much we could do about that, but we could try and assess the risks. But in particular, we dealt with this issue of relatedness, both sort of close and distant relatedness. So there's the familiar kind of close relatedness of siblings, brothers and sisters and cousins, but also there's this idea that what if the two of you come from a remote valley or island or something like that, where certain DNA types are more common, even if they're rare in the main database that the police were holding. So we worked with them and eventually published some papers. And eventually I started getting called in as an expert witness. And it went from there because the problems just got bigger and bigger as DNA profiling was more successful. They got more ambitious about the samples that they could analyze. Very tiny degraded samples were being analyzed, and the results were therefore very noisy. Not all the DNA tests worked. Once you do very, very sensitive DNA profiling, you're pretty much always picking up some contaminatory DNA because, it's a bit of a scary thought, but our environment is covered with DNA. This table in front of me and everything, a door handle you touch, you're transferring DNA all the time. And so therefore, picking out the DNA that you're interested in from the offender or the victim of a crime, that's and separating. Of course, you can't really separate that, but you can sort of kind of mathematically assess that about, whether it's contaminatory DNA, partly things like the strength of the signal, so that the bits of the signal that are the same strength probably come from the same person, that sort of idea. And we could do sort of probability calculations to assess all of that.
So what period of time were you actually doing research into? I assume it's probabilities, or is it a lot more complicated than that?
Yes. Well, I started grappling more general with this, how do you evaluate evidence? And it turns out that scientists are evaluating evidence all the time, and they're not very good at it. But basically, the approach that we thought was appropriate for DNA evidence is you say, how likely is it to see these DNA profiling results if the prosecution case is correct, and how likely is it to see these results if the defense case is correct, and just evaluate those two probabilities. And if the former, the prosecution one probability is much bigger than the defense one, then that's grounds to convict. And we had sort of a whole system of working out this. So it was probability calculations, and we had to take into account all this contamination drop in and drop out, as they call it, of contaminatory DNA, as well as the variation in signal strength. So it took a fair bit of my time over the years. I think I was working pretty intensely for 10 years, but always doing other things as well. I had a regular academic position in London. I was teaching as well and doing research on other stuff. So I suppose it was maybe a quarter of my time or something like that over 10 years or so.
So are we talking theoretical maths?
There's not much new theory. It was the computational complexity of pretty simple elements, so there was some new stuff, but not really mathematical novelty. It was pretty standard mathematics, but it was, applied mathematics applied to complex problems that required a lot of, assumptions. And to some extent, we could work with people at the Metropolitan Police at first, and then later with some of the private forensic science providers. We could work with them to get them to do some experimental results, in the lab to check our theories worked on, mock crime samples that made up in the lab. And the advantage of that is, of course, you know the truth, with different amounts of DNA and all of that sort of thing, and different numbers of contributors.
So it's like using controls.
Yes, that sort of thing, yes.
There was a case called the World's End murders. How on earth did you get involved in that in the first place? And can you tell us a little about the background for those murders?
Yes. Okay. So this was a case called, it's a great name if you want to promote something in the media, the World's End. It sounds very dramatic. It's the name of a famous pub in the old town of Edinburgh that many visitors to Edinburgh will know. And there were two teenage girls last seen in that pub, thus the name, and they were later found murdered. This was way back in the 1970s, before DNA evidence was even really thought of. And It was a very controversial case, a lot of media attention, but nothing happened for a long time in terms of any court case. But eventually it came to trial in about 2007, so this was about 30 years later. And by then, DNA evidence had come along and it got better and better over the years, so that luckily the samples were kept from the crime of various pieces of clothing and ropes that were used to tie hands, and so that had all been kept. But inevitably it degrades over time and was already degraded by the time it was detected. So the DNA profiling was done and found some evidence against 2 men. I think it was reasonably good evidence, but there were lots of sort of questions about this new technology, and they didn't really have the mathematical methods at that point to deal with the complexity of the new, very sensitive DNA profiling. Now, so partly for that reason, but also for other reasons that were quite controversial and I'm not expert enough to comment on, but the judge threw the case out without even going to the jury, and the judge said there was no case to answer because the prosecution had not made a sufficiently strong case. And as I said, hugely controversial, and various senior legal kind of commentators and politicians were appalled by this, and judges were appalled by this. So the controversy kind of boiled on for a while, and eventually the Scottish Parliament passed a double jeopardy law motivated by this case, which allowed in certain circumstances somebody to be retried for the same offence only if there was sufficient new evidence that the new evidence alone could secure a conviction. So that law was passed, and then meanwhile the forensic scientist who'd been involved in the first case got in touch with me and said, well, there might be a retrial, and I'd been working on better methods for the evaluation of these complex profiles. So he got in touch with me and said, well, I need your help in this case. And so by then they were able to reprofile certain samples, and we had quite a lot of DNA evidence, but all of it very complex. There were up to 4 contributors, 2 offenders and 2 victims, plus both the bodies were found in, out in the environment, exposed to environmental DNA, so there's a lot of contaminatory DNA as well. And because this had got so much attention, it went right to the top. The Lord Provost, one of the, the most senior judicial officials in Scotland, conducted the prosecution, and I got to go and meet him several times in his plush chambers in a grand building in Edinburgh, and went over all of this in great detail. It was so complex. I have to say, I was so impressed in this case. Lawyers vary in their ability to deal with this such complex scientific evidence, but he was very good, and the court was very good. So yes, I went through quite a lengthy legal process just to have the decision that there could be a retrial. And then the next year there was the actual retrial, and we went through all this complex evidence. And finally, by this time, one of the 2 accused was dead, but the other one was finally convicted at the end of this long process.
I think one of the issues in the first trial was that it was one man and his brother-in-law who was seen leaving the pub with these 2 ladies, and they were never seen again. And they were found in different locations, and the knots used to tie the restraints and the ligatures were actually different. And that's why it was thought that they were killed by 2 different people as well. Plus, the crime scene police had the foresight to swab everything, collect everything and maintain it, as you said. And the fact that the brother-in-law of one fellow was dead allowed him to then say as a defence, yeah, okay, sure, I had sex with the women, but I didn't kill them. That was my dead brother-in-law who did that. And it's very easy to, raise reasonable doubt when you say, argue with me. The fellow can't defend himself or can't counter any arguments because he's not longer here. So I think it was a bit complicated in that sense. But also what the jury didn't seem to know was that this fellow had quite a violent history and had already, at 16, been convicted of killing an 8-year-old girl, I think it was, and sexually assaulting her. So he was actually in prison at the time.
Yes, for life anyway, so it made no difference to his outcome. It obviously made a difference to the families of the victims to have the case finally resolved.
But I think the really interesting thing about this case is the double jeopardy, because double jeopardy, if you've been tried once and acquitted, then you normally can't be tried again. So I think that was a big issue, passing a double jeopardy law with an exemption.
That's right, yes. And so they set the threshold quite high that the new evidence that wasn't available to the original court has to be on its own sufficient for prosecution without any of the original evidence. So that's a pretty tough standard. And so in that sense, it was kind of lucky that the methods of analysis of the DNA in the first trial were relatively poor and very simplistic, because it meant by the time of the retrial that, the methods that I and others had been developing had gone so far that the DNA evidence was completely overwhelming at the second trial, and that was considered enough to allow the retrial. But having passed that threshold, then at the retrial, all the evidence could be presented, the old evidence and the new evidence, and so it seemed to me a pretty convincing case. But yes, there are all these other potential defence stories, as you mentioned, about blaming the dead one, for example. And yes, I don't know, I didn't have any involvement in that. I'm not sure that was an issue in the end, but yes, it was used along the way.
What was your testimony?
Well, it was just I went through, I think, a couple of dozen DNA samples and went through one by one, where they were located on the victims or the bodies associated, or pieces of clothing associated with them, and we went through one by one about all the possible contributors. As I said, because the samples were so old and quite degraded, none of the conclusions was completely straightforward, but as a whole, the evidence was overwhelming. It just took a long time to be careful about things like, was there any contaminatory DNA? Who, exactly who's of the four people involved, the two accused and the two victims, which of them had their DNA in this particular sample? So all of that took a lot to unravel. It's very complex and technical DNA evidence that must have been very hard going for the jury. But I was pretty impressed with the court, that the way they handled all of that. They allowed me, I think, to explain it to the jury as pretty well. And yes, and of course I was cross-examined. There were a few little issues to raise along the way, but nothing I felt that caused a big problem. So I think in the end it was a pretty overwhelming case, at least in terms of the DNA of those two men was very, very firmly associated with the crime scene.
What were the chances that it was someone else's DNA?
Yes, well, that's very hard to assess. It would have been minuscule, because there are all these different questions. First of all, with so many different samples, it was different for some were stronger than others, and each one of them it was stronger for one versus the other, and sometimes complicated by, it was a bit unclear whether the two victims' DNA was also present. So there's no real easy answer to that question. But we were up into the sort of millions of times, more likely if it came from these two men or one or other of them rather than the other. So nowadays with DNA evidence, we're often into the billions, and it wasn't usually that strong in this case because of the complexities with all the degradation and so on. But it was pretty overwhelming. I think the jury shouldn't have been left in any doubt.
So he was convicted of the sexual assault and murder of these two young teenagers.
Yes, and as I said, he was already in jail for similar offences, and so it didn't make much difference to him. He was given a very lengthy additional sentence so that he wouldn't have been eligible for parole until he was 106, but in fact he died a few years later, so that didn't really change his life course at all, this outcome.
How did that make you feel, having contributed something to help the jury come to that conclusion?
Oh, well, it was a great sense of achievement for me. I'd put sort of years of work into developing these methods and to, resolve this long-standing case and at least bring some closure to the relatives, some of whom were still alive and participating. That was a great sense of satisfaction. This is one of the most complex cases I ever dealt with, as well as being a high-profile case. So it really gave a good sense of that all that effort had been worthwhile. I have also had, I've had that feeling in many cases, although often I give my evidence and leave. In some cases I'm not even there for the verdict. But I do remember very clearly another case I was involved with of an elderly woman who lived alone and was brutally murdered in her kitchen with her own rolling pin. And just sort of quietly over the lunch break, a woman came up to me and introduced herself as the daughter of the woman and of the murdered woman, and she thanked me for the work that I was doing. And that was really a moving experience. That it was just such a wonderful experience to have that personal connection.
You had an involvement in a very famous monarch from a very long time ago. What is an Australian mathematician doing involved in that?
Well, it did arise from the forensic work, and it's a little bit, even though it was a crime at the time, but nobody's interested in the crime angle anymore. They were interested in the identification of the body. But it's quite similar to the forensic work. So basically, famously, the bones had been dug up under the car park in Leicester that could have been the bones of King Richard III. And in fact, they were pretty sure right from the start it was him for a number of reasons, but they needed to try and make a watertight case, a scientific case. But it wasn't actually that straightforward scientifically. There was a lot of evidence pointing to it being him, but some pointing against. And again, so we had this problem of combining different evidence, some of it being weak, some of it actually going the other way, but a lot of it going in the direction of it being him. How do you bring all that together? And so that's when you need to put numbers on the evidence, to put probabilities in order to be able to assess, well, is that evidence that points away, is it overwhelmed by the evidence in favor? And I mentioned earlier that scientists are actually not very good at doing this, so they it was such a big sort of media sensation, this case, that they threw a whole lot of scientific methods at it and got a whole lot of results and didn't really know what to do with the evidence. But just to backtrack a little, the interesting case was the bones were about 500 years old, which is pretty old. So he was the last king of England to die in battle and the only one for 1,000 years whose body's location was unknown. So it was, tremendously exciting, but also hard. The evidence was difficult because of the age. So the normal DNA, most of your DNA that comes in equal shares from your father and your mother, that turns out to be not very useful over such a big time span. So that's what's normally used in forensic work. But there's two little bits of the DNA that are special. Maternal line DNA, so-called mitochondrial DNA, that's passed from mothers to all their children. And then there's the Y chromosome, a relatively small part of a man's DNA, which is only passed from father to son. So the other DNA that you get from both parents, it gets broken up every generation. So over 20 generations, it gets broken up so much that it becomes kind of useless for these purposes. But the maternal line DNA and the paternal line DNA, although only relatively small amounts, only a fraction of your genome, they don't get broken up every generation. And so they're useful over 20 generations. So we had from the bones, I think from the teeth, they managed to extract some DNA, both this maternal and paternal line DNA. At the time, there were official records of the paternal line, and there were some men who should have been descended, not from Richard III himself, because he had no known, his line didn't survive, but his paternal grandfather, Edward III, had some official descendants, so one of them living in Brisbane at the time. And so several of them agreed to be tested, and they didn't match. So that was the kind of counter evidence. Now, of course, there's a sort of obvious explanation that consistent the bones are his, but somewhere over those 20 generations, the officially recorded father is not the real father. Now, it turned out with further analysis there must have been at least two of those misattributed paternity events, because the 5 men who came forward who were supposed to be direct paternal line relatives of Richard III, they didn't match each other either. So it turns out that there are at least 2 false paternities in the royal lineage. So we had to go into, what's the probability in the general population. This is a kind of topic that's always amused geneticists. How many people out there is their biological father not the same as the man who they think is their father? And, estimates have ranged in some cases way up to 20%. But, I think that's a case where the more dramatic result gets the most attention, that the reality is much lower, that, maybe it's around 1% or something like that.
But within the royal family, there are massive implications for legitimacy.
Yes, exactly. But
political, religious, everything.
It's pretty obvious in any royal family. There's going to be some of this going on. And as I said, we found evidence for 2 false paternity events over 20 generations. So yes, we didn't have enough data to get a probability for the royal family, but from a general population, we did get some evidence and put in a figure, and we came out with a kind of figure of it was 6 times more likely, that just based on that Y evidence alone, that it came from someone else and not from Richard III. So that evidence definitely points away from him, but relatively weak because 6 is not such a big number. The maternal line DNA evidence, interestingly, of course, the maternal line being not the line where power and wealth is inherited generally, it hadn't been traced. And so a lot of work had to be done to figure out if there were any maternal line descendants of Richard III's sister. And it turned out that there were. 2 were found, and 1 was a perfect match with the DNA, and the other was just a mismatch of just 1 out of 16,000 DNA bases. So that was pretty strong maternal line evidence, but again, not overwhelming on its own, because because all maternal line relatives would have pretty much the same DNA. There's occasional mutations, but they're pretty rare, and so there could be thousands of maternal line descendants of Richard III's sisters. Just impossible to trace all the lineages over such a long time span. So even though the maternal line evidence did support the case, it wasn't overwhelming. I think we came up with a number of 480. So 480 is much bigger than 6, but it's not enough to be completely overwhelmed. So this is one of the things I kept saying to journalists all the time. The headlines always said, genetic tests prove, and I was very keen to say, no, genetics tests didn't prove. They definitely, taking the both together, they definitely point in favor of being him. But no, there had to be, all the other evidence had to be taken into account. I mentioned the radiocarbon dating. Unfortunately, that didn't turn out to be very helpful, because it did, it's not perfect. And the date it gave as the most likely date was several years, I've forgotten now, a decade or 2 after the death of Richard III. But because of the known level of uncertainty, it did give some support to his lifespan, so it didn't rule it out. And we figured out on the whole that it slightly favoured the case that it was Richard III, but relatively weak evidence. The one thing that struck the researchers when they first found the body was the curvature of the backbone. So that was consistent with scoliosis, as we would now call it. But of course, nobody diagnosed that at the time. And famously, Shakespeare portrayed Richard III as a hunchback. And so there seemed to be some connection, but there's a whole lot of stuff in Shakespeare that's not, historically correct. And so there turns out to be not very much in the official record. You had to be very careful. At those days, physical deformity was very much associated with sort of moral deformity. And so you had to be careful what you said about the king. And most commentators said that he was a sort of fine and handsome man and that sort of thing, because that was the safe thing to say. But there was one visiting German knight that talked about him having one shoulder higher than the other, and it was thought that he was a fairly reliable, independent witness. Not being English, he was a bit freer to say what he saw, and so that was consistent with the scoliosis. But the other thing was that the historical records of him being beaten, physically beaten on the head after the battle, and his skull had holes in them that would have been fatal. So we actually, not we, others did this. I helped synthesize the evidence. I didn't actually go out and do all the legwork, but they actually collected a lot of data from churchyards all over England about how many skulls had holes in them, that would have been as serious as this one, and there were relatively few. So we managed to sort of put that together, and together with the scoliosis. They spent a lot of work on trying to do the genetics of hair and eye color and match that up with portraits, but that turned out to be fairly useless. There was isotopic analysis that told you something a little bit about his diet that was pretty rich in seafood, and that was thought maybe an indicator of high status, but really we couldn't do much with any of that evidence. But with the head wounds, the scoliosis, the DNA evidence, and the estimates of age. It's interesting, actually, that it's not that easy to tell the sex of a skeleton when it's that old, but there were some indications that it was a male. And, of course, from the DNA, we knew it was a male skeleton, but you couldn't tell just by looking at the skeleton whether it was male or female. But all that evidence together, we came up with a figure of 6 million times more likely, all that evidence collectively. So it's pretty clear that there's some judgments going along all the way. It's not really a sort of rigorous, hard and fast science, because everything requires some level of judgment. So we kind of expected some criticism, but surprisingly, when we kind of published these results, we didn't really get any serious criticism. There were still some people. Every now and then someone pops up and says that they didn't think it was him because it could have been this other, but they don't really make any kind of coherent arguments. And so I think that has stood the test of time, and people are pretty happy with the conclusion that it was him.
So why was that car park targeted as a possible burial place for Richard III? Okay,
so we had some historical records that he was buried in a particular friary in Leicester. By now, the friary was long gone. I think it was. It might have been, disestablished under the reforms of Henry VIII, if I remember rightly. And of course, development over the centuries, people had just lost track of exactly where the friary had been. But from historical records, they sort of made guesses as to where the friary would be. It was far from certain, though, that they had the right location. So it was quite amazing that the first place they dug, basically, if I remember correctly, it was pretty much the first day of digging, they found the bones, straight away. It was really remarkable luck because, you could imagine a building that disappeared hundreds of years ago, and with development over the centuries, it's very hard to sort of be precise about that. And even where he was buried in the friary, because it would have taken up a certain amount of space. So they were very lucky to find it quite quickly. That was a big stroke of luck.
What battle did Richard III die in? Did that give an indication as to where he could be buried as well?
Well, it was nearby, the Battle of Bosworth Field, which I also managed to visit on one of my travels around the UK. It's a few miles outside Leicester, so Leicester was the nearest big town. And although he was beaten up brutally by the opposing forces at the end of the battle, I think some of his supporters must have taken the body back into Leicester, and because it was buried in a somewhat prestigious position in the friary, so that was recorded. There was a story that as his reputation sort of got worse and worse over time, thanks to Shakespeare and others, there was a story that he had been dug up and thrown into the river because people were appalled at the things that he was supposed to have done. So there was always some doubt that there wouldn't be any body at all, but it turns out that story, like so many of the stories, was just apocryphal, yes.
In terms of just not picking on the royal family, but they're an example, because Queen Victoria farmed out her daughters to relatives in Europe for marriages, how does what's called consanguinity, which is marrying relatives, how does that affect the DNA and your work?
Yes, so in the case of Richard III, I don't think it made any difference because we were only looking at this maternal line and paternal line DNA. But in other questions, that is important. And going back to the forensic DNA evidence, it does matter because it means your relatives are even, if your parents are somewhat related, of course we're all related at some level, but for most of us our parents are not closely related. But if your parents are closely related or, relatively closely related, that means the similarity of you with some relatives will be even stronger than it would normally be. Basically, if your parents are related, you've got a slightly smaller pool of DNA to sample from at the time of your birth. If you sample half of your mother's genome and half of your father's genome. But if they're related, then a lot of those will be the same. And so that sort of limits the amount of DNA. So that means you've got less genetic variation, which is harmful for certain inherited diseases. But also for forensic, it means higher match probabilities and therefore less certain. I remember one case I was involved in the UK where it was an interesting case for many reasons. One, that the boyfriend of a murdered woman was convicted and jailed for several years, but later they found another man and they said, "Oh, whoops, we made a mistake. We'll let you out of jail and we'll put this other man on trial." Now, so he was from an immigrant community in the UK, and there was a large immigrant community from a sort of small, isolated region of the world about which we didn't have a lot of evidence. And so the consanguinity issue, there was a practice of consanguinity in this community. So that raised the match probabilities. And although we had a very strong case against a particular man in the retrial, or not a retrial, but in the new trial accusing the second man of the murder, there was also moderately strong evidence against his brother. And so it became a sort of bit of a legal question of, can we convict this man if we can't completely rule out the brother? And of course, in the case of identical twins, that can be a real problem, but luckily that's rare enough that it doesn't often happen. But in this particular case, there was some question that the case was just going to be thrown out because they couldn't really deal with this issue of the brother and, having similar DNA profile. And again, it was a case of, degraded. There was just a single hair found at the scene of the crime. And normally it's very hard to get DNA from hair, but they did manage to get some DNA in this case. And as I said, it matched to one man and also partly matched his brother. But I was able to come in and do some mathematical calculations that made it pretty, very, very strongly pointing to the original man and not his brother, so that the trial did go ahead and that man was convicted.
Thank you so much for joining us. We really, really appreciate it. And hopefully this will stimulate or at least intrigue more people into looking at mathematics as a career and how incredibly wide the applications can be. Thanks for making a difference, David.
Thank you, Kathryn.
Crime Insiders Forensics is a LiSTNR original production. It's hosted by me, Kathryn Fox, and is produced by Ed Gooden. Sound design and imaging is by Link Kelly.